All right, you guys, this is chapter 9, lecture 2. Chapter 9 is titled Reconstitution of Powders or Crystals into Liquid Medications. And as usual, my disclaimers are that you must have already read the chapter within your book, review the chapter 9 PowerPoint, and read the chapter 9 lecture notes that were provided to you within Blackboard. So moving on, we have basically gone over a single concentration medication stock label. Now it is time for us to identify a multi-concentration medication. But remember, before on the amoxicillin label, we identified certain components of that label when it comes to powdered drugs. Now we are going to identify some components on this label for this penicillin G potassium for injection label. So let's start off by looking at this 5 million units. This 5 million units identifies, you guys, your total dosage. All right. So what that is saying, your total dosage basically in details lets us know the weight of the powder. All right. So this total dosage is the weight of the powder. Or let's say the total weight of the powder that's in this container. All right. So as we move on, let's go ahead and look at some stuff on to the right side of this label. And one of the things I'm going to pick out here is this information right here. It says preparation of solution, and it tells you, it says diluent added, and it also has final concentration. Well, what does this information mean? Well, as you can see, it has different volumes of your diluent volume. And with each diluent volume that must be added to this total dosage, it gives you a what? A new concentration, or a final concentration. So by looking at this and the definition I've given you guys for single concentration and multi-concentration medication labels, which of the two would this be? Would this be a single concentration or a multi-concentration medication label? Remember, the definition is if you add a diluent volume and you get one concentration, that means it's single dose. But if you add a volume, a diluent volume, or you're given multiple diluent volumes and you get multiple concentrations, that means what? It is a multi-concentration label. So in this case, this label is a multi-concentration medication. So if I ask you what the diluent volume and the final volume is for this label, what you would tell me is that for diluent volume 18 milliliters, meaning that if you add 18 milliliters to the total weight of 5 million units, it gives you a dosage concentration of 250,000 units per milliliter. All right. One of the things that I'm asked, this should be We're going to rename this little section here the dosage strength. Okay. If I add 8 milliliters to that 5 million units total dosage, it'll give me a what? A 500,000 units per milliliter. If I add 4.7 milliliters, my dosage strength now is 750,000 units per milliliter. And if I add 3 milliliters, my dosage strength is what? 1,000,000 units per milliliter. Now let's look at these numbers. The diluent volume. If you look at the diluent volume, the lower the diluent volume is, the higher the concentration is. The higher the diluent volume is, what? The lower the dosage strength is. Meaning that technically the more water you add, what do you think is happening to the concentration or the dosage strength? The more water you add, the less amount of concentration the medication is going to be. The less water you add, the higher concentration or the highest of the concentration the medication will be. So in this case, like I said before, this is a multi-concentration medication. Now, if we look on this label, as we continue to read this label, one of the things that you're going to notice that is not on this label that was on your previous label is your final volume. Your final volume is sometimes given to you in a multi-concentration label, and sometimes it's not. But you always can calculate. You can always calculate your final volume. All right. So again, when I look at this label, the label only tells me what my diluent volume is, what my multiple dosage strengths are, and it also tells me what my total dosage is. But if you're not given your final volume, you can always calculate your final volume by taking the total dosage and dividing it by the weight of dosage strength and then you'll multiply it by what? The volume of the dosage strength. So if you think about it, for each dosage strength here, you're going to get a different final volume for each one. So let me solve it. Let's solve one of these. So for my final volume, let's look at the first dosage strength of the 250,000 units per milliliter. What you're trying to determine is that based off of this dosage strength of 250,000 units per milliliter and the total dosage of 5 million units, what is the final volume of this dosage strength? Well, the final volume is, you're going to take that total dosage which is 5 million units, over the weight of the dosage strength. The weight of the dosage strength is 250,000 units. Remember, when you're setting your problem up, your like units are all set up together. So it'll be unit over unit times, then you'll multiply it by the volume of the dosage strength. The volume of the dosage strength is 1 milliliter. All right. My dosage strength, that volume of that dosage strength is 1 milliliter. So my final volume here is 20 milliliters. So when I add 18 milliliters of diluent to this total dosage of 5 million units, it will give me a concentration of 250,000 units per milliliter with a final volume of 20 milliliters. All right. We're going to keep practicing these problems. This is the end of lecture. This is the end of lecture 2 for chapter 9. We will pick back up in lecture 3 video. Remember, please do not hesitate to send me an email in regards to any questions that you may have when it comes to your practice problems, or just for me to reiterate some things on these videos.